We're now going to begin section 6.3, where we will talk about trigonometric functions of any angle. As you recall, in the last two sections, we have worked with the definition of the trig functions that involves a right triangle. For example, defining sine to be the opposite side over the hypotenuse is based on the idea of a right triangle. We're now going to look at an alternate means of defining those same 6 trig functions. Let's begin with our definition. Given an angle theta in standard position, now remember that means that the initial side of the angle lies on the positive x-axis and the vertex of the angle is at the origin. So we have an angle theta in standard position. We want xy to be a point on the terminal side of the angle. You can choose any point that you want on the terminal side, although it does suggest that you choose something other than 0, 0. And so you can see on our purple angle, they have selected a point xy on the terminal side of the angle. They define r to be the square root of x squared plus y squared. And then we have the definitions for the 6 trig functions. That sine is going to be the y value of our point divided by the r. That cosine will be the x value of our point divided by the r. That tangent will be the 2 coordinates of our point, y divided by x. And note the other 3 trig functions hold the reciprocal relationship. So the cosecant is the reciprocal of the sine, r over y. The secant is the reciprocal of the cosine, r over x. And the cotangent is the reciprocal of the tangent, x over y. This idea of using a point to define the trig functions makes the most sense when we look at an example. Our problem asks us to evaluate all 6 trig functions at theta is equal to 0 if possible. So let's begin by noting where our angle is. So remember that the angle has to be in standard position, which means the initial side lies here. And since the measurement of the angle is 0, we know that the terminal side lies right on top of the initial side. And remember that we want to select a point on the terminal side of the angle. So what I'm going to do, and we have a picture here of our unit circle that we used back in the last section. So what I'm going to do is I'm going to pick the point where the terminal side of the angle and the circle intersect. Now, granted, I don't have to do that because I'm free to use whatever point on the units or on the terminal side that I want, but this is an easy point to work with. Recall that the unit circle has a radius of 1. So think about what the coordinates of that point would be that I noted. That point, in terms of an x value, we would need to go over 1 because that's the radius of the circle, and up 0. So this is the point 1, 0. So in selecting that point, we now have the x value and we have the y value that we're going to use in our definitions. Now we need the r value. So recall that to find the r, we were told to use the formula, the square root of x squared plus y squared. And so we'll plug in our x value of 1 and our y value of 0. 1 squared is 1, 0 squared is 0. So we have the square root of 1, or 1. Now it is worth noting that r, by definition, is the distance from the vertex or from the origin of this on this circle to the point that you selected. So the distance from 0, 0 to 1, 0 is definitely 1. And so especially on a point that lies on an x or y axis, it is possible to come up with the r value without going through the formula. So I'm going to go ahead and note that r is equal to 1. And then we're going to move on and look at finding our trig values. So remember that our definition said that the sine of our angle, which in this case is 0, the sine formula, and we'll flip back, the sine formula is y over r. So we're going to put 0 for the y divided by 1 for the r. And so we can see that the sine at 0 is equal to 0. Our cosine formula at 0 is x over r. So we'll use a 1 for the x and a 1 for the r. And so our cosine at 0 is equal to 1. Our tangent at 0, remember that your formula for tangent is y over x. So we'll use 0 for the y and 1 for the x. And so our tangent at 0 is going to be 0. Now, recall that the other three functions are reciprocals of these three. So the cosecant at 0 is going to be the reciprocal of 0 over 1. So 1 over 0, and remember that that is undefined, meaning that the cosecant does not exist at 0. The secant is the reciprocal of the cosine. So the reciprocal of 1 over 1 would still be 1 over 1, and the secant value would equal 1. Our cotangent would be the reciprocal of the tangent. So the reciprocal of 0 over 1 would be 1 over 0. Again, we cannot have a 0 in the denominator of the fraction, and so it's going to be undefined as well. Okay, so let's move on to another example. Our next example asks us to find the values of the 6 trig functions for the given angles. And we start out with negative 5 pi over 2. So I'm going to begin here. Negative 5 pi over 2 is our angle. I'm going to begin by drawing that angle on my circle. So remember that the angle has to be in standard position, which means your initial side is here. Because the angle is negative, we're rotating down instead of up. So let's sort of count this out. All right, so if I go from here to here, I have gone 1 pi over 2, right? Because pi over 2 is the same as 90 degrees. So if we go 90 degrees, then we have gone a pi over 2. If we go another pi over 2, that takes us to there, that's 2 pi over 2. I'm just counting it around. Straight up is going to be another pi over 2, so that makes it 3 pi over 2. We've got another 90-degree angle here, so that's going to be 1 more pi over 2. That's 4 pi over 2. And we need 1 more, so we're going to come down 1 more 90 degrees, and there is where our angle lies. Now, if that is difficult for you, your other option is to convert 5 pi over 2 to degrees and work it out that way. So whatever you're more comfortable with at this point. Okay, so we'll bring that up just a little bit. I don't know if I can do that easily. Let's see. Okay, I don't know that that helps. Okay, so what we're going to do now is we are going to get this point again where the terminal side of the angle and the circle intersect. So it's going to be down here at the bottom, and we need to think about what that point is. So that point, in terms of an xy coordinate, does not move any to the left or any to the right, so it has a 0x value. And then we go down -1. Now, because I'm running off the end of the screen here, I'm fudging just a little bit, but that point should be on the circle. All right, so that gives us an x and a y. Now, what about the r value? We could certainly use the formula that we used in the last example, or we could say to ourselves, r is the distance from the origin to the point. So how far is it from 0, 0 to 0, -1? It's a distance of 1. Now, keep in mind, distances are always positive because you can't have a negative distance. So the r is going to be 1. If that is confusing, you can always go back and use your formula, and that's fine. And so you would, in that case, plug in your 0 for your x and your -1 for your y and work it out, and you should get the same thing. All right, so once we have our x, y, and our r, we're ready to plug into our formulas. So remember that sine is y over r. So sine of -5π/2 y over r. So -1 over 1, which is going to reduce to 1. Cosine -5π/4. What is your formula for cosine? Your formula for cosine is x over r. So we'll have 0 over 1, which reduces to 0. Tangent, -5π/2. What's your formula? Y over x. So we'll have -1 over 0. Remember, you cannot have a 0 in the denominator, and so that will be undefined. Now we'll do the reciprocals. So for sine, the reciprocal of -1 is still going to be -1. For secant, the reciprocal of 0 over 1 is going to be 1 over 0, which is undefined. And for cotangent, the reciprocal of -1 over 0, 0 over -1, that's going to equal 0. Okay, so let's go ahead and take a look at part B of this problem. Our angle in part B was 120 degrees. So we're going to start the same way. We're going to sketch 120 degrees on my unit circle. So my initial side is going to lie here. Now I need to find 120. Remember that we learned this unit circle by counting multiples of 30. So this is my 30. Remember, we skipped the diagonals. So this is my 60. Add 30 again, we're at 90 straight up. Add 30 again, we're at 120. So here is the angle that we're going to be looking at. Now, what I'm going to do here, because this angle does not lie on the x and y axis, it makes it more difficult for me to figure out what that point actually is. So I'm still going to place my point where the angle on the terminal side intersects the circle. So my point will lie here. Now, what I'm going to do in order to determine what that point actually is use a right triangle. So I am going to extend a line back to my y-axis and then down. Now let's think about what we know about that triangle. We would know that we have a right angle here. We also know that from the 90-degree line to the 120 line, which is this angle right down here, we have 30 degrees. So if we have a 90 and a 30 already in our triangle, we know that the angles have to add up to 180, so this one has to be 60 here. Now, remember what we know about a 30, 60, 90 triangle. We know that the sides have to be in ratio of 1, square root of 3, and 2. All right, so I'm going to write that down. So a 30, 60, 90-degree triangle, the sides have to be in ratio 1, square root of 3, and 2. So that means that I could label across from the 30, I could label this side 1. Across from the 60, I could label this side square root of 3. And across from the 90, I could label this side 2. Now, what does that tell me about my point? All right, so think about, in an algebra class, going from the origin to that point. So we would go over a certain amount. So how much would we go over? We would go over the same distance as what we have up here. So we would go over 1, and it technically would be a -1, right? And then we would go up to get to the point. And when we go up, we're going to go up the same distance as what we have on the other side, which would be a square root of 3. So the coordinates on this point would be -1, positive square root of 3. Which tells me now that I have an x value of -1 and a y value of square root of 3. Now, there certainly is an easier approach to doing this that we're going to learn in a little bit in this section, but I wanted you to go ahead and see this because you'll see this in the homework, the idea of drawing that triangle to determine what that point is going to equal. All right, so let's finish up this problem. We've got the r formula, so let's use that here. R is the square root of x squared plus y squared. So we're going to plug in -1 for the x. We're going to plug in square root of 3 for the y. -1 squared is 1. Square root of 3 squared is 3. 1 plus 3 is 4, and the square root of 4 is 2. So we now have an r value of 2, an x value of -1, and a y value of square root of 3. So let's go ahead now and plug into our formulas and get our answers. So our sine of 120, remember your formula is y over r. So we're going to have square root of 3 over 2. For cosine of 120, x over r. So we'll have -1 over 2. Tangent of 120, we're going to have y over x. So square root of 3 over -1, which is going to reduce to negative square root of 3. The other three trig functions are our reciprocals. So cosecant of 120 is going to be 2 over the square root of 3, which we will need to rationalize. Multiplying top and bottom by square root of 3, we come up with 2 on the square root of 3 over 3. For secant, we'll do the reciprocal of the -1/2, which will be -2. And for cotangent, we'll do the reciprocal of square root of 3 over -1. And again, we'll need to rationalize. And we end up with negative square root of 3 over 3. And that concludes our second example. Again, in our next section, we're going to talk about an easier approach to finding the trig values for an angle like 120. In general, if your angle lies on the x and y axis, then using a point is a great way of finding your 6 trig functions. If your angle lies inside one of the quadrants, not on the x and y axis, then perhaps there's a better way that we'll look at in just a few minutes.